So I'm actually delighted to be able to have Peeyush with us. Please have a seat, Peeyush. Thank you so much for joining us today at the day 3 of the Airflow Summit. One of with the introduction, which I would definitely want to introduce Peeyush, is he's the founder and CEO of Weave.ai, which is an AI company for the insurance technology space, for the insurance space. And his part of his goal is to help transform the insurance industry with AI technologies and AI copilots. So with that, Peeyush, I think I'd love for you to kind of introduce yourself and also to kind of give a far more detailed view of what Weave does than I can.
Sure, absolutely. Vikram, thanks for having me here. It's a pleasure to meet all of you. So yeah, like Vikram said, so we serve the insurance industry via AI copilots. They are agentic applications. For those of you who are not familiar with insurance industry from a technology and system standpoint, they have a pretty complex underwriting and claims process. As consumers, we don't see that the complexity from the outside, but internally they have a fairly complex process involving lots of unstructured data coming from various different sources, mixed with structured data, and then a lot of humans in the loop for decision making. So that, so far, as we all know, right, with the older language technologies, which were fairly narrow with NLP and stuff like that, it was very difficult to leverage the value and the power in that unstructured data. But obviously, with the newer large language models and newer transformer architectures, we are able to do that much more now. So when we started Weave AI almost 3.5 years back, the goal was to really build the foundation on those technologies so that we could actually address the value extraction from the unstructured data and human decision making. So that's sort of evolved into our agentic AI copilots. What they help the underwriters do is not, we'll talk about where the state of the agentic AI is today in practical sense. But the reason why we call our application copilots is because they assist the underwriters and the claims adjusters to perform their job. So it's like a assistant as opposed to something that just takes over their role because we are not there yet. So that's what we do. We are, focusing on a segment of the insurance industry, which is called the commercial property and casualty domain. It's a insurance industry from the inside is extremely complex and diverse. So we focus on one aspect of it. My background, in context of today's discussion, I've been working with AI and data for many, many years, built several enterprise products and solutions over the years. One thing that, I've been using consistently across my last few companies is Airflow. And that's why, when Vikram and I were talking about this event, I was quite passionate about sharing my experiences and the evolution of Airflow as a technology that I've been using over years. And yeah, very excited to talk about that today.
Awesome. Thank you, Peeyush. One of the things which struck me, I think we started speaking about this about 2 years ago, I think, almost pretty early in your journey when you were using Airflow and Weave was kind of starting to grow. One thing which was quite interesting for me is that you've got a product or a service which is shipped to your customers and made available on all 3 public clouds, which is based on Airflow. And I think that's a lot of learning in that on how do you actually run the same product, leveraging Airflow on all 3 public clouds, and what are some of the challenges in this distribution, in leveraging this across the 3 public clouds? Any learnings on that front? Because I think that's a common thing which we see even for internal services about enterprises wanting to be multi-cloud, and you're actually doing this as a commercial service on, I think, all 3 public clouds. So that's why I was curious.
Yeah, absolutely. I think when we sell software products to the enterprise, you have to, unless you are a SaaS offering where you have your own cloud and then the users access it as in a SaaS model, the type of application we develop is, core to the internal sort of operations and business processes of the insurance companies and other enterprises. And they are very sort of particular about data privacy, security, data not going out of their cloud, right, of their private cloud. So from the onset, this is a learning that I've had over the last many years developing software for the enterprise, that you have to be able to deploy it in their private cloud. And what that translates to is, if the customer is on Azure, you have to deploy on Azure. If they are on AWS, you have to deploy there. And if you're on Google, you deploy there. So architecturally, you have to make a few choices, right? I would say in some ways, it adds a little bit more burden in your architecture. But when you're deciding on your systems architecture, you have to consciously stay away from using any cloud-specific proprietary technology or service or API, right? Because if you do that, then if you go to another customer that's on another cloud, then that becomes a challenge. As an example, we obviously dealing with unstructured data, we have to use OCR engines. Each of the cloud providers provide their own OCR engines. There are third parties also, but we actually had to build an abstraction for the OCR to support Azure's OCR, Amazon Textract, and then Google's own thing. And then also in some cases we have to open it up for any third party if the customer chooses. So the way we have been handling this, Vikram, is by building the right level of abstractions in our architecture so that we can plug in the right service. Another example is Kubernetes, right? Many of these customers deploy using Kubernetes, and each of the cloud providers have their own sort of version of Kubernetes. So you have to sort of comply to those. But architecturally, if you keep this abstracted, then you have an easier time managing this, right? So those are the decisions you have to make when you go for an abstracted architecture that can deploy anywhere. In fact, we can even deploy on-prem, right? So for us, it doesn't matter what the underlying compute infrastructure is. Most of the large language models are available via an API today, so that becomes less of a challenge at the moment. But eventually, right, that will also, when customers and enterprises start hosting their own private models, then that will also be a consideration. And I think the API abstraction would be important there.
Awesome. So the next question, I'd actually like to kind of get back into the insurance space itself. You mentioned claims and adjusters and underwriters. What are some of the workflows you actually implement? I mean, because with Airflow, we tend to think about workflows. And what is the workflows you're actually serving, and who are the constituents of those workflows?
Yeah, absolutely. And I would like to show you a slide which I have, which will sort of give you the idea of the complexity of some of these things. But this is just you don't need to understand this slide, but it shows you the complexity of a process within insurance companies. So, underwriting process, I'll just give a high-level view, right? So what happens is a business applies for insurance, and the business has, let's say, multiple buildings, multiple vehicles, multiple employees. Now, when the insurance company looks at this data from the business, their customer, I'm talking about commercial insurance. It's like several folds more complex than me buying a car or me buying a house and getting insurance from that. That's a very simple or relatively simple data point, right? Because there's lots of data about individuals. But when it comes to business, they have to look at where each of their buildings are, what do the employees do in that business, right? They may be working in factories or restaurants or whatever it is. And that changes the risk profile of that business. And as you guys know, insurance is all about measuring the risk of what you are basically going to provide the premium for, or you charge the premium for. So what you see here is a process that typically, most of the commercial insurance companies have to go through. On the left-hand side, you see all the different types of documents and data feeds that are coming in. You have to augment that with third-party data. So, for example, if your building is located in New York or in Florida, it has a very different risk profile. One is, in a metropolitan area. The other one is in a flood zone. And similarly, there, in California, there is a fire and earthquake, So all these aspects are different for different states, different, and those guidelines apply to when an underwriter is taking a decision. If the business has buildings all over the place, they have to look at guidelines across these places. And then they have to look at history of the data. What were the prior claims or losses, as they are called, that came through? So all that stuff has to be input into the the decision making of underwriting, for example. Similar process happens with claims, but underwriting is way more difficult because you are actually trying to be profitable with that decision as an insurance company. The other dimension to this whole thing is insurance is not just one insurance. Insurance can be for general liability, for the property itself, for your employees, for your vehicles. So it's, when you talk about the commercial insurance, all those dimensions also come into picture. And as an insurance company, I may want to write some of those and not want to write some of those because they could be unpredictable and too risky. So then you have to consider the lines of businesses, and then you essentially go and make a decision, right? So it's a very complex process. For commercial businesses. It could take weeks, sometimes even months, depending on the complexity. And that's the main thing. And what happens is that if I, as an insurance company, take 3 weeks to respond to the broker with a quote, and another insurance company takes 2 weeks, they will win the business. So accuracy of decision and the speed of decision for any insurance company is very high, and that's what we provide. So you look at on the right hand side, we have these obviously AI agents evaluating all these scenarios based on the guidelines. So what the underwriters would do manually today, our AI agents do that work, and they present that work to the underwriter, right? And then they, of course, review it. Based on the confidence score, they can drill down into certain aspects of the decision making, and then the scorecards guide them objectively. The reason why scorecards are important is because it brings a objective decision making framework, as opposed to making a human judgment, which can differ from one underwriter to another underwriter because they have different expertise, experience, different views of the world. So that's the complexity we deal with. It's actually very interesting, and I'm not even talking about some other complexities, because sometimes what happens is insurance is not one product. Sometimes you have to buy insurance in layers. It's called excess and those kind of things, for those of you who are familiar. So you may want to have coverage over I, as an insurance company, can provide you, let's say, coverage up to $10 million. What happens if the losses are more than 10 million? Then another insurance company comes and says, I will cover anything excess of 10 million. So it's the complexities are, multi-dimensional, and it's very interesting, problem to solve. But yeah, that's I would say that's one way to look at it. And similar things happen on the claims side. There's another very not very well-known aspect of insurance, which is called premium audit. Certain insurance companies are, by regulation, required to audit their policies with, that they have issued. Because what happens is that sometimes you issue a policy and the business changes, right? Business, let's say I buy new buildings, or I hire new people, or start a new business unit, and suddenly during the year, my business profile changes, my risk profile changes. So I have to, adjust to that as an insurance company, so that policy audit is an important thing. That's a completely manual process today, and that's another product that we are launching, later this year to help with co-pilots on the premium audit side.
That's awesome context, Peeyush, for sure. But now the tech part of me is kind of very curious.
Yeah.
So how does Airflow fit into this, whether it's Airflow 2 or Airflow 3. I can't resist kind of looking at this thing which says data set. And I kind of go, is this actually a data asset? And all those kind of questions start coming up. I mean, this is probably not your direct DAG and data asset structure, but on the other hand, I'm kind of curious to hear from you.
Yeah.
How does this apply?
Absolutely. So you can see the complexity in this process. Now, imagine if we are trying to run this process for a customer, a new business application comes in, and we have to process it in a certain amount of time with certain accuracy and reliability. That's where Airflow comes in. And so when we started building the platform, one of the first things we did was the foundation of the platform was on Airflow, because if you think about this process orchestration across this cycle, this is a very, very complex workflow. And we have the Airflow as the base. The Airflow calls the AI agents at the right time, right? So if I were to go back to this is a highly simplistic view of, how we have implemented it, but this is one step in that underwriting process, right? So with Airflow as the base, right, we orchestrate the process from the point where data comes in, right? So there's an ingestion process, the Airflow workflows, we built workflows for ingestion that pulls in the data. Then when we need to have agentic decision-making, then Airflow invokes the agents seamlessly. So we have built those, basically the tasks in Airflow that integrate with our AI agents. They make the decision and then hand it back the decision to the Airflow. And then at certain thresholds, it brings in human in the loop. So, and then that's one of the reasons why I'm really excited about the latest version 3.1.0, is that it now incorporates that human in the loop capability within the workflow definition itself. You don't have to do it outside and do workarounds and so on. But this is the realistic sort of scenario, and that's why we rely on something like Airflow to really provide that whole orchestration of information going from ingestion all the way to decision, right, at every step. And if that technology is not reliable, then that's a big risk to not only us, but to the business, to our customers. So that's sort of the backbone of our platform. Yeah.
So one question, Peeyush, is email submission, is that like, event-driven? So when you get a new, what do you call it, a new submission? I mean,
it's an email that has, like language written about the broker telling the insurance company, this is the business, these are the characteristics, and then have 10 attachments. They have a spreadsheet, they have PDF documents, they have a bunch of stuff. And it's not just one email. The same broker can send multiple emails about the same business over time. So, yeah. That's the event.
So that's the event which starts triggering the workflows.
Exactly.
Then you actually gather all the data about the risk profiles and about which location and all that kind of stuff.
Exactly. So the ingestion basically does two things, right? It essentially sees whether I have all the information that I need to underwrite this. Sometimes they may forget sending, the loss reports, which are important for decision making. Sometimes they may not have information about a property, how, what's the square footage, what was it constructed, what was the construction material, who occupies the property today. So all those aspects are done at the ingestion layer, and we come up with a completeness and a quality score for that. And then we augment it with our AI agents going to third-party data sources, right? So this could be just going to a website, getting information about something, or there are, in the insurance world, as you guys probably know, there are lots of data providers that provide an API to, I give you an address and they will give me all the data about that building for, let's say, fire or earthquake or flood or construction, right? So you have to go to multiple data sources, get that information, and then see, okay, do I now have enough data to make a decision, right? So that is what the ingestion does.
Got it. And so the next one is the evaluation about, is this a good decision or not?
Yeah, so I've given, this example is about one step, which is appetite. Appetite, what it means is, if I'm an insurance company and I get a request, I may or may not want to write that business because, as an example, I'm an insurance company that does not write buildings in California, and this is real. There are some insurance companies that don't underwrite California properties. So let's say the application comes in, and the business has 10 buildings, and 2 of them are in California, right? My appetite evaluation will trigger that, saying that, oh, in my appetite guide, we have mentioned that we won't underwrite buildings in California, and in this data, I know that 2 of the 10 buildings are in California. So my appetite score will go down, and it will trigger, right? Now, if it goes down to some extent, but it's above the threshold, I will still go ahead, right? Which is the decision there. But if it is below that threshold, then I will send it for human review. That's the workflow. So the appetite, and like I said, appetite is just one step. The whole underwriting starts after that, which has several other steps, but just as an example.
Cool. You going to do a demo?
Yeah. So, I'll basically do a demo of this particular process here. Okay, there you go. So I'll explain as it's happening. So this is our, underwriting workbench or Copilot, right? We are triggering a new process called clearance, which basically is something that every insurance company does. So now that process has been triggered, and now we are showing the workflow instance. Now, we obviously, for our users, we have abstracted. This is Airflow, basically. What you see here is an abstracted view of Airflow. We have an abstraction to visualize the Airflow workflows. You can see that workflow is working. It's directly taking from the DAG definitions and showing this, and it's progressing. And you can see that the status is getting updated, right? So this is now running, and when it reaches the human in the loop task, right, it will trigger an event, right, based on the score. So you'll see that. Okay, now it's gone, and it's now waiting for human review. So in our real application, of course, we will have a user interface which will call the human in the review API that is there. But for the purposes of showing you guys, this is what it looks like. So now with the 3.1.0, we can now actually trigger this process where the human in the loop comes into picture. You have the possible responses like clearance or send for review, and that was clicked, and now the workflow automatically starts. So the power here is that I don't have to build 2 or 3 different workflows and do some orchestration outside. We can now do it within Airflow, and that's really powerful, and I'm really excited about that. Now the workflow is finished, and the process can move forward to the next stage. So this was what you saw is actually Vikram was gracious enough to provide us with an early release of 3.1.0. We integrated it, and what you saw is a real live recorded demo. I didn't do it live here, but this was actually integrated, and we are now starting to implement a native human in the loop within 3.1.
Awesome. Thank you so much to you and your team for putting that together. I think it's 2 weeks since we released 3.1.
Yeah.
So that is really quick to be able to see that. What is kind of the workflow while you actually have this screen up? Is this like how your application looks to your customers?
Yeah. So this is what we have done is we have built, because we want to have an integrated experience for our users and customers. The underwriters will typically not go here and view the workflow because they really need to be underwriting, and there's a workbench view for them. But the administrators of the process would sometimes come here and see. And so if you look at the information that is here, right, we could actually view the logs of each step, right? Again, for maybe debugging or figuring out what's going on there. We also log, duration of each step so that we know. You can see that this workflow took 3 minutes, right? And that way we know that clearance process from the beginning to end will take 3 minutes. It's important because in some businesses, if they don't respond in 15 minutes, it's a problem for them. So, tracking and measuring these things are important. So what we have done is we have basically, built an abstraction on top of Airflow, which gives us these APIs to get all this information and visualize them. And so if I go and change the DAG, you'll start seeing the new DAG automatically, and it will just show up. It's all data-driven.
So two questions actually. One immediately is, you said you clearly work across different clouds, right? And different AI models and agents. How do you keep them consistent? Because one of the problems with AI models is their different models come up with different answers sometimes. And how do you actually keep this consistent across different clouds and different AI models? I mean, how do you do that?
Yeah, that's a great topic, Vikram. So we are also agnostic to the large language models that we use on the platform. I think the key to using LLMs, as some of you may already be practicing and learning, and we have been learning this for the last 3 years, right, building this platform and working with customers. If you think about it, there are a few options in front of us, right? We have the OpenAI. That's one big commercial LLM provider, and we are largely driven by LLMs. So, right, we consume those APIs a lot. We do use some NLP models, narrow NLP models, but those are for specific purposes. So, OpenAI is one option for us. Anthropic with their Claude models is another option for us, and then we have the open source options, right? Now, the capabilities of all these three categories of LLMs is very different. OpenAI is like a uber, very powerful model. They're their largest model and the most powerful model. They are now offering smaller and faster models, which is a great option to have because it's cheaper and faster. Claude is sort of now developing the competency more in terms of the code and the developer community. That's where they are going with they are sort of establishing a niche there, and they are probably better than OpenAI in that segment. But overall, OpenAI is definitely more capable. It's also more expensive. And then we have the open source guys, which are at the moment lagging behind, right? Because they're the nature of the beast, right? They don't have billions of dollars to pump into training and improving those models. So this is the ecosystem today, but in my view, in the next 2 to 3 years, the open source models will become capable enough for the regular use cases and decisions. I don't know where, how much further the commercial guys are going to be able to push the envelope. I believe all the AGI stuff is marketing hype right now. We need a fundamentally different model architecture to reach that, if we ever reach that. But practically, we deal with all these models on a day-to-day basis, and they are still very vulnerable. Right? We can't just ask them to do complex tasks. So the trick is, how do we make an enterprise-grade decision accurately with these kind of technologies? They are not deterministic. They are probabilistic. You don't know what the next answer is going to be. So the way to sort of handle these is to you guys, I'm sure you have heard of the word context. So the context that you provide to these models is very, very important, right? If you throw in a whole document to the model and start asking very precise questions, it's not going to be able to give you the right answer. It's going to hallucinate or give you ambiguous answers and so on. And every time you ask, you'll get a different answer. So that's the challenge today, right? So as you can see, we are far from anything AGI. Also, let's say if I were to orchestrate this whole thing using an AI agent, right? There is, I would say, less than 10% chance that orchestration will be reliably executing the same path every time. And that's why when you want a consistent process, you need something like Airflow to have a deterministic orchestration, but use the agents for non-deterministic decision-making at the steps, right? So I would not take a risk today to say I'm going to have an agentic flow to run my entire underwriting process, because that will be a disaster, right? So how do we reduce the context is, as we are going through, you can see the information coming in from the left-hand side. As you move right, we start building these knowledge graphs, right? What are knowledge graphs? They are abstracted view of certain business objects, which are not everything. So as an example, a claim could be a knowledge graph or a business object. Now, claim has a specific definition for every company, every insurance company. And that claim knowledge graph is sort of populated with the information that we get from these documents. And we have various techniques of doing that. A mixture of sometimes we use RAG. We have our own sort of form generation capabilities that we have invented that gives you a 99% accurate answer from those things. So now you have a knowledge graph which is 99% accurate. It can never be 100%, but 99 is unheard of, right? I mean, even if you put humans to extract it, you'll get much, much less. Humans can get to 70, 75%, right? Because of inconsistencies in how we think. So if I have a 99% accurate business object, now I can use that to make decisions, right? So and the context is that business object, not the whole document with a bunch of words and sentences that are irrelevant, and the model is being forced to understand that, right? Models can understand JSON objects much more unambiguously than 10 pages of information containing the same information. Right. So that's an important step to reduce your context, make it very relevant to the questions you're going to ask, and then ask a very precise question. So once you have a knowledge graph and say, okay, you have a lost date or a date in which the event occurred when you're doing a claim, and you have policy start date and end date. Right. Now you say, okay, I'm going to pass you the lost date and the policy start and end date. Tell me whether it's within the range of the thing. That kind of questions I can ask because it's a very narrow question. And I think the models have become good enough. 2 years ago, they were making mistakes in this also, right? It's a very simple question. If you ask a 5-year-old child, they will be able to tell you that accurately. So now they have grown into a situation where they can answer these kind of questions, but you have to break down the problem into this simple context and a simple question or a precise question, which will give you a precise answer. So the trick is to reduce ambiguity, reduce confusion for the model. It's like treat the model as a 5-year-old child and you're trying to get a consistent response from that child. That's how we have learned to control the things. And then we can apply this technique to any model and we will get a relatively consistent and precise answer, right? So that's how we can work across models. That doesn't mean that we don't have to work. It's, you can't build one set of prompts and assume that it'll work for every model. So we do have to change the system prompts and some of the user prompts to make this work, but it's possible. It's a bit of work, but it's possible to be agnostic. And some of our customers, they are on AWS, they just don't want to call any API in Azure, which basically rules out the possibility of using OpenAI models. So we have to use Claude. At some point, we haven't encountered a Google enterprise customer yet, at least in the insurance world, but at some point we will. So yeah, that's hopefully gives you some insights.
Great. I mean, actually, that was very insightful. There's one other thing which I just wanted to make sure to ask is, do you also use AI as a judge for prior AI answers as well? I mean, you did mention human in the loop as well.
Yeah.
But I kind of recall from our conversations in the past that you were exploring using the AI as a judge to validate the results of a prior AI model. Is that in flight?
Absolutely. Yeah. I think Vikram, that's a great point you brought up. So, I was talking to Vikram the other day, and this is something that we also learned talking to our customers. So, I think last year, you probably heard a lot about human in the loop, and yes, obviously, it's very, very important to have human in the loop. But so beyond the theory of that, when you come into practice and you talk to customers and say, if the confidence is low, you can bring a human in the loop, right? Now, the customers started telling us, that sounds good, but where do I get the humans from, right? It's a cost. It's, you can't take your underwriters and start asking them to evaluate stuff if confidence is low. Even if they have outsourced things, it's not, outsourced services are actually even less reliable than, from a human in the loop standpoint, than AI models sometimes. So that's what, the pattern of, LLM as a judge or evaluation agents, this was emerging. We actually implemented it early on in our platform, where we now use, when the result is given by our primary model evaluator, we actually evaluate that result using 3, 4, 5 other agents. And it's not just to ask the same question and get the same answer. We use a bunch of different techniques, adversarial techniques, different techniques to get the answer, negative questions, all these different ways. And let's say if the 5 agents are evaluating this, and you still get the same answer, then you have almost 100% confidence that that answer is accurate. But if 3 of them agree and 2 of them don't agree, then there's a lower confidence score. So that's how we have implemented this AI as a judge or an evaluator, framework in our platform. We have to recognize that by doing this, we are increasing the cost. But is that cost more than having humans in the loop? And is it more accurate than having humans in the loop, right? So that's the determination one has to make when we make this decision. Now, after these agents evaluate, and then you have a low confidence, then you bring the human in the loop. So we believe almost 85% of the evaluations can be done by AI. The 15% that fall in that middle or low range of confidence can be surfaced to humans. And that actually reduces the cost of human capital that required to get an accurate decision by almost 85%. So that's how we have actually done it.
Awesome. That's awesome. Thank you so much for sharing that. I think just in the interest of time also, one last question for you. We have talked quite a bit about what you'd like to see in Airflow. You've already done Airflow 3.1. Sure, like a lot of the people, you've got a lot of Airflow committers here and contributors as well. What else would you like to see with Airflow going forward?
Yeah, I think, Vikram, when we were talking last year, I think, which you guys have already addressed now, one sort of challenge earlier was how do we seamlessly transfer data between tasks? I think that has been now addressed, or it's partially addressed, right? And so I think when we talk about context, right, this is where that ability to start a workflow and then take that context across the multiple steps of the workflow and make it available for the steps to access it. I think that's going to be an important thing because, like I said, context is very, very important. So quickly having access to that and being able to invoke an agent would be an important thing, right? Second thing would be, I think, from an agentic AI perspective, probably adding some of these native tasks, just like you've done human in the loop. We know the universe of agents now. There is more or less, and there are abstracted APIs for calling LLMs as well. And then there are now MCP type of frameworks that are emerging, which allow you to build more interoperable agentic communication, right? So incorporating those at the core, just like we have done for human in the loop, I think in the next versions, if that is available, then we can still, all these things we could always build outside of Airflow, but if it is available in the DAG itself as a framework, then it becomes much, much easier, several folds easier to build that workflow, incorporate the agentic communication and all that. So I think it would complete this picture, which is, right, how do we orchestrate these things very seamlessly, right? The core Airflow tasks, agentic tasks, and human-in-the-loop tasks seamlessly via Airflow. That becomes a great sort of platform to build your workflows then.
Awesome. Thank you so much, Peeyush. That was a wonderful talk.